All right, hi, I'm Gary from Science Central, and this is Katie, and we're going to talk to you today about the weather in our wild weather demonstration. So, what do you know about weather? What do you know about the weather outside? Today, when we came in to do this filming, it was kind of cloudy today. It looked like it was going to rain. We had some really thick clouds, and I think the weather forecast called for thunderstorms later this afternoon. So, do you know what a person that studies the weather is called, Katie?
Oh, I don't. Do you know, Mr. Gary?
They are called a meteorologist.
Oh.
Which I find as an extremely funny name because, I honestly thought, Katie, that a meteorologist studied rocks from outer space. Meteorites.
That makes sense.
I know, but they study weather. And I hear they have a really hard job, too, because there's a lot of things that go into the weather. There's ocean temperatures, there's wind currents, there's seasons, there's air pressure, there's hail and sleet and snow and storms and a whole bunch of stuff. So it's not surprising that every once in a while the weatherman or meteorologist is wrong on their weather forecasts. But we're going to take a look at some of the basic things that cause the weather and do a few experiments here and see if it'll help you make the weather make sense, I guess. So let's start out by everyone taking in a great big breath of air. Ready? And hold it and let it out. You just breathed in 78% nitrogen and 21% oxygen. Those are the main elements or air molecules that make up the atmosphere or air here on Earth, or I should say ground level, because the atmosphere is made up of many different levels. It's kind of like if you slice an onion in half, you see all of those circles? If you picture the Earth as being the center, all those different layers of an onion would be the atmosphere, and all of those different atmospheric gases, do you know, push down on us?
No.
Yeah. So air takes up space because it's made of little particles, and the air makes the atmosphere, and all of those particles are being pulled down by gravity, and all of those layers are pushing down too. So that's where we get air pressure. And right now, on you and I, we're getting pushed on by 14.7 pounds per square inch of pressure. Can you imagine that?
No.
Wow. It is like if I took this 1 inch by inch square and placed it all over my body, it would be like a 15-pound bowling ball would be sitting on top of that square. You would think that if I had all of those little squares on my body and a 15-pound bowling ball on each one of those squares, that I would be pushed down flat as a pancake, right? But surprisingly enough, our bodies are designed to live in this air pressure, and we have an equal pressure pushing back out on us. So we are at equilibrium, or the pressure pushing on the outside is equal to the pressure pushing on the inside. So let's take a look at that. Katie's going to help me here with our balloon. Now, in science, we always have to remember safety first. So let's put on our safety equipment just in case something goes wrong with our balloon experiment. So we're going to put on our safety goggles and our ear protection, just in case something crazy might happen. All right, Katie, let me show you what I'd like you to do. So we're going to start out with our balloon here. This balloon is at equilibrium. So there's an equal amount of pressure on the outside and the inside. So that's why it's called equilibrium. It's equal. Now I'm going to have you take our balloon here and add some air to it with our air pump. Now, as Katie adds air into our balloon, we can see that air is made of particles and takes up space because our balloon is getting larger. Now, there's now high pressure inside that balloon because she keeps pushing more air particles into that balloon, which means that the pressure around the balloon is low pressure. Now, pressure always likes to go from high pressure to low pressure. Now, if Katie keeps pumping that balloon full of high pressure, what do you think is going to happen? It's going to explode, and it's going to go to equilibrium really fast. Well, we don't want that to happen because I want to show you, thank you, Katie, how air pressure likes to go. Because air pressure likes to go from high air pressure on the inside to low air pressure on the outside, because it likes to go to equilibrium all the time. So high air pressure likes to go to low air pressure. So let's take a look at that again. All right, for this experiment, we are going to use a device called Magdeburg hemispheres. So this is an interesting device. It's made out of two spheres that are going to be placed together to form one sphere. So this is named after a town in Germany called Magdeburg, Germany, where there was a scientist who liked to do air pressure experiments. And when he did this experiment, he had these two huge spheres that he used with teams of horses. We couldn't fit teams of horses together in the studio here today, so we're going to use the small sphere to show the experiment. So what he did is he took the air out of these two halves of the sphere. So I'm going to hook that up to our, can you hold these for a second for me, Katie? I'm going to hook this up to our vacuum pump. Turn that on. And we are going to take some air out from between these two spheres. And so we're creating low air pressure inside this sphere versus the high air pressure on the outside of this sphere. All right. Now, this is a really good demonstration of that air pressure we were talking about, that 14.7 pounds per square inch, because there's now 14.7 pounds per square inch, get my 1 inch back, on each section of our Magdeburg hemispheres. And since there's low pressure on the inside and high pressure on the outside, what do you think is going to happen? Think I can pull these apart really easy? Let's try. Oh, wow. That air pressure is really, really strong. Maybe you should help me, Katie. Wow. That 14.7 pounds per square inch of air pressure is really, really strong. So let's see what happens when I push this little valve here and see if I can open it up. Because we have low pressure on the inside and high pressure on the outside. Where does air pressure like to go? From high to?
Low.
All right. Not sure if you could hear that, but there was a small hiss of that air pressure moving, and on the count of 3, 1, 2, 3, we were able to pop it open because the air went back to equilibrium. All right. So that's air pressure for you. That's one of the parts that we deal with in weather. Now let's take another look at those air particles. Let's take a look at those air particles and heat. So for this, I'm going to need all of your help out there. So this is a chance for you guys to participate because I'm going to turn all of you guys into air particles. On the count of 3, are you ready? 1, 2, 3, whoosh! You are now all air particles. So air particles, the reason why I turned you into air particles is air particles act a lot like people. And Katie and I, we're going to use our hands to demonstrate how those air particles act like people, and we want you to join along with us. So, when it's hot outside, do those air particles, like people, do we like to get close to each other? When it's hot, we like to be way far apart from each other. And those air particles like to do the same thing. They like to spread out, and they like to rise up into the air. So hot air particles like to rise up into the air. So you guys can all stretch with us as we rise into the air. Now cold air particles are also like people. When it's cold outside, do you like to be far apart? Or do you like to huddle up next to each other and kind of group together? So those cold air particles like to group together. And they group together and then they like to sink. So hot air particles like to rise and cold air particles like to sink. So if you think about this is how a hot air balloon works. When you have those burners on the bottom of a hot air balloon, they send hot air up into the balloon, and those hot air particles rise and stretch out, which causes the balloon to float. And then they turn off the burners and cool down those air molecules, and they let out the air molecules as they sink, and the balloon sinks with them. So that's how hot air molecules rise and sink. So I'm going to turn you all back into yourselves again. Ready? 1, 2, 3, and whoosh. All right. Now for this next part, we're going to use that hot air rising and that cold air sinking to look at another aspect of weather. Imagine now, use your imagination and imagine that you are sitting on a nice, warm, tropical beach. You're on this nice hot sand, the nice blue water is out in front of you, and there's a cool breeze coming in off of that cold water. And that cold breeze is caused by that rising and falling of air particles, because that hot sand is heating up those air particles above the sand. And what do those hot air particles like to do? They like to go up and rise. And out there above the nice blue water, those cold air molecules, what do they like to do? They like to bunch together and sink. So as the hot air molecules rise and the cold air molecules sink, we start getting those molecules changing positions, and they start going in kind of a circle, and they create a wind. So as that warm air is rising up on the beach and that cold air is sinking over the water, that cool tropical breeze, because of the replacement of those air molecules or movement of those air molecules, starts to cause the wind. So that's why you get a cool breeze coming in off of the ocean or the beach, wherever you're at, that water. So that's kind of the way that those air molecules move. Those hot air molecules going up and those cold air molecules going down. Now let's take another look at that, but for that, let's look at it with a different experiment. On the count of 3, ready? 1, 2, 3. All right, so let's look at those hot air molecules rising up in the sky. Now for this, we have our hot air device, which is a lot of old-fashioned light bulbs that get really hot. Those fluorescents are extremely energy efficient, and the nice thing about them is that they're cool to the touch. The old-fashioned incandescent light bulbs, they provide a lot of heat for us, which is a great way to show you this experiment of those hot air molecules rising. Tongue twister there. So let's take off our safety equipment, Katie, real quick, because this is going to be pretty bright. We're going to need some sunglasses. All right. Now, to demonstrate those cold air molecules falling, while we don't have our hot air device on, and it's pretty cool above there, let's toss out some talcum powder to see what it looks like or what it does. So as you can see, all of our powder particles are kind of falling. A few of them are hanging in the air, but for the most part, they're all falling down to the ground, because that's that cold air falling down. That cold air is also pulling those particles down. So why don't you hit the switch there on our hot air device. We'll let this warm up just a tad here, and we're going to create some hot air above these lights. Now let's see. So as that hot air goes up into the atmosphere, it takes small particles with it. So it'll take small particles like this powder that we've got here. It'll take pollen and dust and smoke, and it takes it up into the atmosphere, which is very important for our next experiment. But let's watch those particles rise. So as I add that air or those particles to the air, you can notice that really lightly those particles are moving up. We'll do it one more time across here. So instead of like before where those particles dropped really fast, those particles are kind of hanging in the air. They're kind of moving up. You can kind of see that smoke of that baby powder moving up into the air. Those are those hot air molecules grabbing a hold of that dust and moving it up into the sky. All right, now remember, those particles are going to be important for our next piece of weather. Let's go to our next experiment. Ready? 1, 2, 3, and we're back from our last experiment. We're going to talk about now how important those particles that were rising in that hot air are to the weather, because those particles are the formation of the next thing we're going to talk about, which is clouds. So we are going to make a cloud here in this jar. Katie, do you know what goes into making clouds? There's 5 things.
Air?
Yep, that's one of them.
That's all I got.
Well, that's a good start. So we have air, we have water, we have those particles that were rising up in that hot air, and then we need low pressure and low temperature. So it takes about 5 things, which is kind of crazy. So as the air around us have those particles and those air molecules are floating up, those particles collect water or water vapor. And as that water vapor goes up into the atmosphere, it starts getting cold. And as it gets cold and there's less pressure, because they're not down here with that 14.71 pounds per square inch on the Earth, they start to form a cloud, or the technical word is condensation. So let's do a cloud experiment in our jar here. So first we need some air. I'll add that to it. Next we need some water. Can you hand me some water? Thank you. Next we need some particulate matter. Now for the particles, I'm going to use some match smoke. Now remember, matches can be very dangerous. They're not a toy, so if we ever have to use matches, make sure you have a responsible adult working with you. So let me strike these real quick. Let them burn just a little bit. I'm going to drop them into our tank so we can get some smoke going. Now to lower that pressure, we're going to use our vacuum pump again. And as we lower the pressure in here, we're also going to lower the temperature. Now, Katie, I'm going to have you take this flashlight so you can have us help us, or should I say help us, watch this cloud form. On the count of 3, 1, 2, 3. Now, we start lowering that pressure, and if you notice, our cloud starts to form. It starts to get a little foggy inside of our cloud jar. That's that condensation. The water molecules collecting or condensating on top of those dust particles in that low pressure and low temperature to form a cloud. Now, what do you think is going to happen when we go back to high pressure? Let's see. Our cloud disappeared. Let's try that one more time. Let's see if we can capture our cloud again. There we go. We dropped that pressure, dropped that temperature, and we still had enough air particles and water in there to form another cloud. So on low pressure days, we get really cloudy days, like today when it looked like it was going to rain. A lot of clouds in the sky, we get that low pressure. And then on sunny days, those are what we call high pressure days. And when there's high pressure, that high pressure pushes all of that low pressure out of the way and pushes all those clouds away. So that's why you have, on a sunny day, we have not a lot of clouds in the sky. And on a low pressure day, it's usually raining, or it looks like it might just about ready to rain. So that's how our high and low pressures work with our clouds. Now, with that high air pressure and that low air pressure and all of those hot air particles going up and those cold air particles going down, with that wind moving across the surface of the earth, and with all of the different pressure areas and temperatures, sometimes we get some pretty crazy weather. That's a good mix for the storms that we get into, especially around the springtime, especially when you have high pressure and low pressure coming together in what we call in weather a front. And as those fronts mix and that hot and cold temperatures and particles are moving around up there, we start getting rain. Now, a cloud like this is kind of like a sponge. It can only hold so much water. So as the cloud gets too full of water, it starts to rain, or what we call precipitation. And as that rain falls, depending on the temperature down here on the earth, we either get rain or snow, or sometimes sleet and hail. And sometimes those storms or that rain can be really violent, because what happens is sometimes you get that warm air. What does warm air like to do? Likes to go up, and that cold air likes to go down. So you get warm air trapped under cold air that's pushing it down, and that sideways motion of the wind starts getting sucked up in that warm air, and we start getting a phenomenon called a funnel cloud or a tornado. Now, we all know what to do when there's a tornado warning, right? You want to seek shelter as fast as you can and get to an area of your house that's protected from the wind and the windows and any kind of flying debris. That's because tornadoes, even though that funnel cloud is very dangerous, the wind that's associated with the tornado is also very dangerous. Now, a tornado wind speed can range from a very small tornado at about 75 miles an hour all the way up to a large tornado at over 230 miles an hour. So, on our last experiment, we're going to show you why it's so important to seek shelter. So let's go do that. Ready? On the count of 3. 1, 2, 3. So for our next experiment, we're going to take a look at that wind speed of a tornado in our tornado wind speed simulator. So for this, we are going to take a common household pencil, and we are going to see what happens when we expose this pencil to a 75-mile-an-hour wind through a nice piece of drywall. So this is a standard piece of drywall, which is what your house walls are covered with. And I'm going to have Katie draw us a house right on our piece of drywall. So, as Katie draws our house, you guys all remember what to do in case of a tornado. You remember when you want to be in the center of your house in a low area, away from any kind of windows or anything that's going to break or fly around. And this is why. I'm going to give that to you. And Katie, can you step over here? Because we're going to be shooting our pencil that way. I'll let you hold on to our projectile. All right, so we're going to put our house into our tornado wind simulator. And then take our pencil, add it to this end. Now for our wind, we are going to be using a canister of carbon dioxide. I'm going to attach it, double check. Make sure we get all of our safety devices set. I'm going to turn this on. All right, on the count of 3, we're going to launch that pencil. Ready? I want you to count with me. Ready? 1, 2, 3. And let's see what happened. Oh my gosh, Katie. Our pencil went right through our house. So that's pretty crazy. It's pretty dangerous too. If that pencil went through that drywall without any problem and at 75 miles an hour, imagine what it would do to your body. So always remember, stay away from flying objects during a tornado warning or any kind of severe weather. So that kind of wraps up our wild weather demonstration. So let's do a quick review. So high air pressure likes to go to
Low air pressure.
and hot air molecules like to go up, and cold air molecules like to go
Down.
And the 5 things that make a cloud are?
Air, water, particles, cold air temperature, and low air pressure.
Perfect. And what do you do in severe weather for a tornado?
Get out of the way.
All right. So I know we're not at Science Central right at the moment, but we do have a tradition at Science Central that if you had fun and you learned something, we would like you to yell with us, "Science is fun," on the count of 3. So I'm going to give you the count of 3 and join with us and say, "Science is fun." Ready? 1, 2, 3. Science is fun!